Good afternoon, viewers. So now I'm going to revise whatever the topics we discussed in GATE classes. So first we started with the linear algebra. Linear algebra. First we started with the linear algebra. So in the linear algebra, we have discussed matrices. First we discussed definition of matrices and its types. So in the types of matrices, we have discussed equal matrices, equal matrix, and then diagonal matrix. Equal matrix means, so the order of the matrix should be same as well as all the entries in the matrices also should be same. Diagonal matrix means non-diagonal element should be 0 and all the diagonal elements should be non-zero. So that is nothing but the diagonal matrix. After that, we have discussed identity matrix. Identity matrix. Identity matrix means in the diagonal matrix, if all the diagonal elements are 1, then we call it as identity matrix. After that, idempotent matrix. Idempotent matrix. So if it is A square equals to A, if the square of the matrix, if it is equals to A, then we say that it is idempotent matrix. After that, periodic matrix. Periodic matrix means with the A power K plus 1 equals to A. So then we say that A power K equals to A, then we say that P is periodic, K is the periodic of that matrix. So next, nilpotent matrix. Nilpotent matrix. Nilpotent matrix. So nilpotent matrix is nothing but if A power n equals to 0, so then we say that n is the order of the nilpotent matrix. Involutory matrix, after that involutory matrix. And then followed by transpose of a matrix, skew symmetric matrix, symmetric matrix, orthogonal matrix, upper trigonal matrix, lower triangular matrix. Like this, we have discussed all the types of matrices. After discussing all the types of matrices, we have solved few problems based on what's that type of matrices, checking whether the function matrix is an idempotent matrix, whether it is a periodic matrix, whether it is nilpotent matrix. Like that, based on that, we have discussed a few problems checking whether the matrix is the given type of matrix. So then we moved on to which one? Determinant of a matrix. Determinant. So here we have discussed definition. What is the definition of the determinant? After that, mainly properties of the determinant. Properties of determinant. So we have also discussed few application oriented problems based on determinant, how to find out the solution, or by using the inverse of the matrix, how we can find out the solution of system of linear equations, or how we can find out the inverse of a matrix by using the determinant. So those based on the topic, we have discussed a few problems from the determinant of a matrix. And then we moved on to rank of a matrix. Rank of a matrix. So rank is nothing but what? The number of non-zero rows present in a row reduced echelon matrix. So then we say that the number of non-zero rows. So that is nothing but the rank of a matrix. So here, so this rank of a matrix will be helpful for finding the solution of the system of linear equations. So system of linear equations means there will be two types, Ax equals to b. So this is the main form of the system of linear equations. Here, if it is b equals to 0, then we say that it is homogeneous system of linear equations. Homogeneous system of linear equations. If b is not equals to 0, then it is non-homogeneous system of linear equations. So here we have discussed so many cases how when the shortcut methods are like when it will be the system of linear equations will be having unique solution, or in which case it will be having infinite solution. So like that cases we have discussed. The simple method is if the determinant of A is not equals to 0, for this homogeneous system of linear equations, then it will be definitely it will be having infinite a unique solution. If it is not equals to 0, then it will be unique solution. If the determinant of A equals to 0, then it will be having infinite solution. Or in terms of rank of a matrix means if the rank of A which is equals to n, so that is nothing but the number of unknowns in the given system of linear equations, so then it will be having unique solution. So we know how to find out the rank of a matrix by expressing the matrix into row reduced echelon form. And if it is the rank of the matrix, if it is less than n, then it will be having infinite solution whenever the given system of linear equations are homogeneous system of linear equations. After that, we discussed non-homogeneous system of linear equations. Non-homogeneous system of linear equations. So in this one, non-homogeneous means first you have to find out the rank of the augmented matrix. Rank of augmented matrix. So if it is equals to n, which is same as some rank of the coefficient matrix A. So then it will be, we call this one as consistent matrix. The given system of linear equations will be consistent. If it is not equal, so that is rank of the augmented matrix A is to B. If it is not equals to rank of A, then it will be inconsistent. Inconsistent means there will be no solution. So, but in consistent, there will be two cases. If n equals to, if the rank of augmented matrix is equals to rank of the matrix, if it is same as number of unknowns, then it will be having unique solution. If n is less than the number of unknowns, then it will be having infinite solution. So by using this shortcut method, we have discussed a few problems, how to check whether the system of linear equations are existing solution for the system of homogeneous linear equations. If it is existing, how many solutions will be present, either unique solution or infinite solution. Like that, we have solved few problems based on homogeneous as well as non-homogeneous system of linear equations. After discussing the homogeneous and non-homogeneous, just we moved on to eigenvalues and eigenvectors of a matrix. Eigenvalues and eigenvectors of a matrix. Eigenvalues nothing but the solution of the characteristic equation determinant of A minus lambda I equals to 0. So here lambda is nothing but the eigenvalue. We will get the root. So this is nothing but the eigenvalue. For finding the eigenvectors, just you have to consider the equation A minus matrix form A minus lambda I into unknowns, which is equals to 0. So just you have to consider this form to find out the eigenvectors. So based on this, we have discussed properties of eigenvalues and eigenvectors. So for example, the sum of the eigenvalues will be equals to trace of the matrix. The product of the matrix is equals to a determinant of the matrix. Product of eigenvalues is equals to the determinant of the matrix. So like that, based on properties of eigenvalues and eigenvectors, we have discussed so many problems. So after completing this one, just eigenvalues and eigenvectors, we have moved on to next topic, that is calculus. So this is also one of the main topic. So in this one, we have started our discussion with the very basic concept, that is function. So function is nothing but some mapping. So from one set to another set, f from A to B. So here A is nothing but domain and B is nothing but codomain of a function, and range of the function will be f of A, so that is so which is a subset of B, so that is nothing but the range of the function. So here in function we have discussed some standard functions. What will be, so what are the some standard functions? Standard functions like identity function, constant function, modulus function, sine function. Later we have discussed the continuity of that functions also, continuity, differentiability, that is calculus of that functions. We have discussed all of those standard functions. So it's followed by the one more important concept, that is limit of a function. How to find out the limit of a function at some particular point. It may be some finite point or it may be infinite point. So this limit of a function we are going to use while checking the continuity of a function also. We have discussed so many problems based on limit of a function and continuity of a function, which is followed by differentiability of a function. Differentiability of a function. So if you know a thoroughly limit of a function, how to find out the limit of a function, then we can directly easily check whether the function is continuous, and differentiability also. So because the same continuity and differentiability will define in terms of limit of a function. If you know how to check the limit of a, how to find out the limit of a function, then only you can check whether the function is continuous or not. After checking for the one variable, that is limit of a function, and then continuity, differentiability, we have discussed applications of differentiations also. Applications of differentiation. So here we have checked, we have discussed problems like based on what is that, finding the maxima or minima of a function, or checking whether the function is increasing function or differentiation or is a decreasing function. So based on that, we have discussed a few problems based on maximum, minima, as well as increasing and decreasing function. After that, we have discussed partial differentiation. Whenever the function is depends on only one variable, then we have to apply, derive the function ordinarily. In case if it is depends on more than one variable, then you have to go through the partial differentiation. So it may be function of two variables or function of three variables, or it more than whatever it may be, more than one variable is there, means you have to apply the partial differentiation. So here we have discussed how to find out the partial differentiation of a function whenever it is function of more than one variable, and followed by how to find out the what's that, a Jacobian of a Jacobian, and then how to, in which case you have to apply the Euler's theorem. So these are the few concepts you have discussed while in a partial differentiation, which is followed by applications of partial differentiation. In application part, we have discussed maxima, minima. So once again, we have discussed the same to find out the maxima and minima of a function of two variables, followed by total derivatives. So these are the application we have discussed, and we have discussed a few problems also, how to find out the maxima and minima of a function of two variable, and how to find out the total derivative for the function of two or more than two variables. After partial differentiation, we have moved on to next topic, that is integral calculus. Integral calculus. So in this integral calculus, we have discussed how to find out the integration of any function, especially standard functions like trigonometric, polynomial, and then hyperbolic functions. And mainly this integration we divide into two types. That is, one is definite integral and then indefinite integral. For this definite integral will divide into two types, proper integral and then improper integral. So proper means the limit value should be same and value of the integral should exist. So then we say that it is improper, a proper integral. In case one of the limit is infinite or value of the integral, if it is not exist, then we say that improper integral. In this definite integral, we have discussed so many properties based on definite integral. And even we have discussed a few problems based on that definite integral, how to, by using the properties, how we can find out the value of the integral. And then after this, we have discussed application of integration. Application of integration. So such as finding the area, length, and volume related problems. We have discussed these type of concepts related to area, length, and volume problems. We have discussed based on integration. So after this topic, we have discussed complex analysis. Complex analysis. So here the main thing is analytic function. The same concept whatever we have discussed earlier in differential calculus, that is finding the limit and continuity and differentiability. The same thing you are going to check it for the function of two variables, that is complex numbers. So here the main concept is analytic function. So and we have discussed what is the definition of the analytic function and what are the necessary conditions for a function to be analytic, that is CR equations. And based on this CR equations, that is checking the whether the function is analytic or not, we have discussed so many problems based on that. And it's followed by harmonic function. Harmonic function means a function which satisfies the Laplace equation. So that is nothing but the harmonic function. And we have discussed a few results related to analytic function and harmonic functions, like real and imaginary part of analytic functions are harmonic. So that means, and based on this, if they given real or imaginary part, means how to find out the another part, or if they given only one real or imaginary part, means how to find out the analytic function. So those type of problems we have discussed in this part. After that, we have discussed complex integration. Complex integration. So here the main theorems for the complex integrations are Cauchy's theorem, Cauchy's integral theorem, and then lastly Cauchy's residue theorem. We have discussed what is the statement of the Cauchy's theorem and then Cauchy's integral theorem. So these are the theorems we'll use while finding the integral values. And Cauchy's, before Cauchy's discussing Cauchy's residue theorem, we have discussed what is the pole, what is the singularity, what is the pole, what is the removable singularity, what is the essential singularity. All those properties we have discussed, definitions. After that, we have discussed Cauchy's residue theorem also. So these are the Cauchy's integral theorem and Cauchy's residue theorems. So these two theorems will play a crucial role while finding the complex integration. So lastly, we have discussed probability. So in this topic, we have discussed simple problems related to probability by using the, what is that, permutation, combination, what are the combinations, what is the permutations, and discussed even definition of the probability also and properties of probability. So that is all the probability should be lies in between 0 and 1, and some of the probability should be equals to 1. After that, we have discussed what is the mutually exhaustive events, and mutually exclusive events. We have discussed definition of these two mutually exclusive events and properties related to these mutually exhaustive and mutually exclusive events, and we have discussed problems based on probability. So these are the few topics we have discussed in our GATE classes. I hope all of you have understood those concepts, whatever we discussed in classes. So just to go through the notes and you make just to collect the previous year question papers and prepare well for the exam. All the best, students, and thank you so much, all of you. Thank you all.